Mrs. Lee, and this is the midterm review video. So hopefully you can work through these together. I'm not going to go through all the problems, but similar types of problems I'll be going through. And feel free to fast forward to the things that you need to do. I'm going to do them in numerical order. So if you're looking for problem number 50 or some type of thing that's like number 50, skip on ahead. All right, let's get started. So today we're going to be going over, so on the midterm I should say, we're going to be over operations of polynomials. So this one is just adding. So please make sure you're looking at in between the parentheses, because if there's nothing there, like for example, like number 5, that just means that we're multiplying. And these, the number 1 and number 3, those are, we have operations there, so we are going to be adding and subtracting those polynomials. So basically think about it like combined like terms. All right, so if I look at here, since this is a positive, I distribute the positive, none of the signs are going to change. If you want to rewrite it, you can. I usually don't, just because that's a lot of work. All right, so I'm going to look for the biggest exponents. That's because I'm going to write this in standard form. So that's what I'm going to do. So 8x to the 4th power plus 3x to the 4th power is going to just be 11x to the 4th power. Remember, we do not change the exponents on that. Okay, that's how we determine whether they're like terms or not. Let me use other colors here. The next one is going to be to x to the 3rd power, and that is the only one I have. So I'm just going to add that right in there. When I say add, I mean like subtract. And then going on to the next one, x squared. So here's, I have 2x squared, so it's negative 8 x squared minus 3x squared, so that's going to be negative 11x squared. All right, we're adding two negatives together. And then we have our last one right there, which is just the 4x. I like to underline them. You can star, like some people put a check mark above them or cross them out. I usually don't like to cross them out just because I can't see what it was before. Some people like scribble them out. Don't do that. Or some people put squares in boxes. I'm using different colors so I can kind of see which ones I've done. So I know I've tackled all of those terms. So then, and I already have them written in standard form. So that's the answer. The end. All right, number 3, very similar to number 1. The only difference is that's a minus. And so whenever you have a minus, you have to distribute that negative with everything, because multiplying by a negative does change the units, not the units. What is it called? The signs. All right, so this is what I'm going to do. So I'm going to make it a plus, negative, negative, negative. So if, let's say, if that, instead of that being a plus, that was a minus, then that would have turned into a positive or a plus. Okay, so it's just the opposite of whatever we're seeing there. Okay, and I make those straight across there. Anything inside the parentheses gets affected by that. Okay, the one after it, not before. See, these ones, no effect. All right, now just doing like what we did before. I start with my biggest exponents, which happens to be on the outsides. So 3n to the 3rd power plus negative 4n to the 3rd power is going to be just negative n to the 3rd power. If you want to say negative 1n to the 3rd power, that's fine. But we normally just say negative n to the 3rd power. And the next one, I don't have any n squares, so I'm looking for the n's. And so negative n plus negative n is going to be negative 2n. Make sure you think about those when you're doing that. A lot of people like to cancel those out, which is not a thing. So then we have this right here. So negative 5 plus negative 7 is going to be negative 12. And we're done. Already in standard form. All of my terms were used. Happy days. Okay. Next one right here, we're going to now notice inside between the parentheses there is nothing there, which means we're just multiplying at that point. All right, so some people like to use the box method, other people like to distribute. I'll show you both ways and you can decide which way you want to use. Either way, you're going to get the same thing. So here's the box method first. Some people call it the area method, area model. Either way is fine. So this is the length of one side. So I like to put this one on the left-hand side. You can put it on the top. It doesn't matter as long as they go on one of the sides. And then 2b, or not 2b, just kidding, minus 1 is going to be on the top. So you can switch these around. That's fine. And then we're just going to multiply. So think of like the multiplication table. So the way we get this one this answer is you multiply the 7b times 2b, which is 14b squared. All right? And then to get the one below that is negative 4 times 2b, so which is negative 8b. All right? And then over here on the second column, 7b times negative 1, which is going to be negative 7b. And then negative 4 times negative 1, which is going to just be positive 4. So please don't just leave it like this. That's not the answer. That's how we get to the answer. So I'm just going to go with 14b squared, and then these two diagonals, those are like terms, so that's negative 15b, and then we got plus 4. Remember, it's a plus 4 because that's a positive 4. All right, and I'm going to show you a distributive model. This is the one that it's just the standard way of doing it. This is the way I learned how to do it. So we're going to take the 7b and we're going to distribute it with both of these two terms. Let's see, both of these two terms. So 7b times 2b is going to be 14b squared. And then we're going to multiply. Let me see if I can get the different colors going. 7b times negative 1. 7b times negative 1 is going to be negative 7b. Do you see how we have similar things there? It should be exactly the same. And then this negative 4, now we're going to distribute the negative 4 with both of these two terms. So it's going to be negative 4 times 2b, which is going to be negative 8b. See, negative 8b right here. And then we're going to have the last one. So negative 4 times negative 1, which is going to be positive 4. All right? And then again, just like how we did for the area model, we're going to have to combine like terms. So that's just going to be 14b squared. These two middle terms, that's going to be negative 15b, and then plus 4. So do you see, either way, we're still going to get the same answer. You just decide which way works best for you. Okay, what's going to lead to the least amount of mistakes. All right, and please practice those ones right here. This is what we call simplifying expressions. All right, next we're going to start factoring. So we're going to factor all the things. All right, remember the crisscross method? We're going to be using that. First, we're going to check, is there a GCF here? And I noticed the x squared has a coefficient of 1, which means there's no GCF, because it would just be 1, and we're not pulling that out. And then I noticed that there's no x here on the 6, which means that there's no variables to pull out. So let's go. X times x is going to give us x squared. So we have two things that multiply to x squared, which would be x times x. And then right here, what are two numbers that will multiply to 6? We'll deal with the negative in a bit. And since this has no coefficient, I'm thinking what and also adds up to 5. So that would have to be 6 and, it could be 6 and 1, or it could be 2 and 3. Right, because 2 times 3 is also 6. But let's see if this works. So now this is where the crisscross happens. We're going to multiply x with a 6, which we get 6x, and the x with the 1, which gives us x. And then so I want it to be negative 5. So the top one, the 6 has to be negative, which would make that negative. So that's going to be negative 6. Oops, sorry. Just kidding. Negative 5x. You didn't see that. All right, and also let me just check, because negative 6 times 1 is negative 6. So yeah, this is the one we should use. And notice again that this negative 5x is the same as that middle term right there. Happy days. So again, we're going to go straight across. So x minus 6, just like that. So x minus 6. When our a is 1, so when there's no coefficient here, the going straight across doesn't really matter because they're both x. But once we start getting different numbers for the coefficient, that is really going to matter, as you'll see in a bit. So this is going to be x plus 1 since that's a positive 1, and that's your answer right there. All right, x minus 6, x plus 1. And so if we were to multiply this all out like we did for number 5, we'll get back this answer of x squared minus 5x minus 6. I should say expression, not answer. All right, moving on to 13. Now again, we're going to check the GCF. Can we pull out a number? And I know that I can pull out a 3 on these ones. If you're a little bit weak on your multiplication tables, it'd be a great time to review that. Or we're going to use our calculator now. Well, oh no, it's dark. All right, I was staying still too long. All right, and so 3 times what will give us 9a squared, and that's going to be 3a squared. You can also think about we're dividing 3 from the 9. Uh, you can think about it that way. So 9 divided by 3 is 3. Because remember, multiplying and division is, they're not kind of, they are inverses of each other. Plus 48 divided by 3, which is going to be 1/16a. And 60 divided by 3 is going to be plus 20. There we go. So on your calculator, you can just go 60 divided by 3, and that will give you this other number right here. And then again, so 3 times 20 is going to give us 60. All right, so now that I factor out the GCF, and I notice this is a 3, that's a 16. 3 does not go into 16, so there's no more GCFs from here. So now I'm going to do the crisscross method. So I know one of them has to be 3a, and the other one has to be a, because the only way we can get a 3 is one of them's 3 and the other one's 1, right? And this one is going to be 20. It needs to multiply to 20. Doesn't have to add up to 16 because remember we're multiplying one of those terms with 3. So here, 4 and 5, 5 and 4. Let me think. I'm trying to think of the orders. Oh, that's going to be 12 plus, ooh, that's not going to work out. 10 and 2. Ooh, 10 and 2. You can't see me smiling because, so 10 and 2. I'm just trying to do things in my brain so I don't have to rewrite it because, as you can see, I'm writing in pen. So again, 3a times 2 is 6a, and a times 10 is going to be 10a. And if I add them both up, because they're both positive, that would give me a 16a, which is exactly my middle term. So happy days. All right, so now now this is again, like I said, we're gonna go straight across, and this time you really have to go straight. You can't go a plus 10. That's not gonna give us the right answer. So 3a plus 10, so again, 3a plus 10, that's our first factor, and our second factor is a plus 2. Okay, and if you were to just be like, that's my answer, you would be direly wrong. Remember that there was this 3 out here. So put that 3 right out there, and that is now completely factored. All right, next one. This one seems to be the hardest for most people for some reason. I don't know. But it's just the binomial, and we're going to see, well, what's the GCF? Like we've been checking, what is the GCF? And if you know that is a 6 and that's a 10, which means they're both divisible by 2 because they're both even. So I'm going to pull out a 2 because there's no other numbers that would go into that. And I notice that they both have at least one r, which means I'm going to pull out one r because that's the max I can pull out. And so if I divide 6r squared by 2r, I would just get 3r, right? And if I think about it, 2 times 3 is 6, r times r is r squared. So that's how I know that works. Minus, well, this is going to have to be just 5. So 2 times negative 5 is negative 10. R times nothing is just r, right? So here, that's it. This is linear. There's nothing else to do. This is the answer. That's it. No crisscross, no nothing, right? Because they're both linear. They are no more factorable. I don't know if that, you know what I mean. All right. Next page. We're on number 18 right here. And this is also binomial. There is no GCF here, but I notice that this is x to the third power. And 125, I'm familiar with 125 because I know that's the cube of 5, right? You got to just be familiar with these numbers. All right, so, and again, the way you tell that on the calculator, let me turn it on first, is we're going to do the cube root. So if you look at that, there's that x root. So put 3 first to indicate that's going to be the cube root, and then second, and then the one above the caret. And then so you should see that one with the x, and then we're going to put 125 and push enter, and then so you get here 5. So remember that 3 is not saying this 3 times the square root of 125. That's just saying it's the cube root of 125, which is 5. Okay, so that's another way you can check if, you know, on the midterm you blank out. That's not good. So again, so I know that these are both cubes, so this is the difference of cubes. All right? Difference of cubes, something to remember. All right, so I'm going to just set this all up. I want to look exactly like this so we can figure out our a's and b's. So this one has to be just x. We already know that the cube of 5 is going to give us 125, so that's going to be 5 right there. All right, and you're going to remember, have to remember SOAP, right? Well, plus all the a's and b's and all the things, right? So here we go. Remember, it's a minus b, so it's the same. So x minus 5 times, so remember this is our a, this is our b. It's going to be a squared, so it's going to be x squared. And then it's going to be opposite of this sign, so it's going to be plus a times b, so x times 5, or we call that 5x, and then always positive, and then that's going to be b squared, which is going to be 25, 5 squared, which is 25. All right. You may want to look up the form for a difference of cubes. Make sure you write that in your 1 page of notes. All right, so this is now fully factored. Happy days. All right, without that form, you're not going to be able to do this one. So make sure you got that one down. All right, and then this one right, oh, and again, if you want to write that down for difference of cubes, is for a, I know. So this is going to be a minus b, a squared plus a times b plus b squared. So the a, b's, and the a squares and the a, b, and the b squares, that's always going to be the same for difference of cubes, or even a sum of cubes. The only thing that's different is going to be the signs. Okay, those are going to be opposite signs right there. All right. All right, so this one right here, I noticed, okay, first, I always check the GCF. This coefficient is 1, so yeah, no GCF. For numbers, this one does not have an x to pull out, so therefore, no GCF. So I noticed we also have 4 terms, so I'm going to try by grouping, because that's the only one I've learned, or that we've learned, how to factor, right, by grouping. So I'm going to take the first 2 right here, the first two terms, and I'm going to think, okay, what can I pull out of this? What GCF can I pull out here for the first 2 terms? And so I'm like, okay, they both have an x squared. So I'm going to pull that out. All I have left is just an x plus 2. All right. Then I'm going to go to my second 2 terms and be like, okay, what can I pull out of here? So I notice that both of them, I can take out a 5 from them, and I can take out a negative 5 for a good reason. All right, because what do I have left is just x. Instead of now that being a minus, because I pulled out that minus, it's now going to be a plus. That's going to be 2. So again, negative 5 times x is negative 5x. Negative 5 times 2 is going to be negative 10. Right? That should work. If it doesn't work, then you did something wrong. Right? And the reason why I pulled out that negative is because I want this to look like the other parentheses. All right? So now I have the big GCF of these 2 factors. And I know that the GCF is x plus 2, so I'm going to pull out x plus 2. Oop, darn it, I already have parentheses there. And then what do we have left? Try to do this in colors. So I like to use my fingers to kind of erase those. And all I have left is x squared minus 5. So I'm going to write x squared. And I did it in purple, so minus 5 in purple, to kind of show where they all came from. All right. And then I'm going to just check, can I factor more? On the left-hand side, it's linear because there's no exponent there, so no, I can't. This one is x squared, right? But this 5 is not a perfect square, so we're just going to leave it like that. We're only going to factor more if it's a perfect square. We're just going to go, that's as much as we can do. All right? Please make sure you're practicing more. Do all the other problems. Remember, the answers are in the back. All right, so now we got solve equations. So we got simplifying expressions, we got factoring, and now we have solving equations. Okay, we got to solve for x, or solve for the unknown, and in this case, solve for n. So I notice this is a quadratic. So there are 3 ways, but I'm just going to show 2 ways. All right, so the first way is, what is it called? Factoring. Factoring is probably the easiest way to do things. And if I'm thinking to myself, 2 numbers that multiply to 35 and add up to negative 12, the only ones I can think about is 5 and 7, and 5 and 7 do add up to 12, so we'll use factoring. Factoring, honestly, is you'll have less mistakes that way, but sometimes you can't factor it, so, you know. All right, and the only way we're going to get this equal to negative 12 is if they're both negative. So n times negative 7 is negative 7n. This is just my check. N times negative 5 is negative 5n. And that added up together is going to be negative 12n, which, yes, they are the same. Do you have to do a check? No. If in your brain you already know that it works, then do it. But this is a good check just in case. Because sometimes, you know, if I don't write it out, I make mistakes. All right, so now again, we're going to go straight across. So n minus 7, and this is going to be n minus 5. And this is in factor form. Don't forget the equals 0 because we're actually not stopping here. We need to solve for n, right? So remember, if we have two factors that are multiplying, which means that one of these two have to equal 0 in order for this to equal 0, right? So we're going to just use the zero product property. So we're going to go n minus 7 is equal to 0, and n minus 5 is equal to 0. All right? And you can think about it logically, or you can think about it, you just solve for n. Either way is okay. N is equal to. So if I think about some number minus 7 is going to give you 0. Well, what does that some number have to be? 7. Like 7 minus 7 is 0, right? Another way you can do it is if you just add 7 to both sides, you know, like how we would normally do them, and then like algebraically, and then we get the answer of n is equal to 7. So I'm running out of room here. So again, that's going to be 7. This one right here, if you do it the same way, some number minus 5 is equal to 0. So again, your number would be 5. So we have two answers here, which we normally expect for quadratics, right? Two answers. Remember, these would be like our zeros, you know, on the graph, our roots, right? All right, and we're going to try number 29, right? Again, same idea here, but if you notice, ooh, number 7, negative 7, can't have that. Remember, we need to get it equal to 0, so we have to do the additional step of getting rid of that guy, which is add 7 on both sides. All right, and then we get 3x squared minus 31x, and 49 plus 7 is going to be 56 is equal to 0. And now we can start talking about either factoring or quadratic formula. I'm going to try, because quadratic formula seems, well, okay, I'll use quadratic formula, but I really do think you can factor here. Okay, I'm not looking at the answers for these ones, so, you know, I wouldn't know. Let's try it out. I thought that would be more useful so you can see what's going on in my head. So we're going to try the quadratic formula. I'm not looking forward to it, but that is all right just because it's long. So a is going to be the coefficient of that x squared, and b is going to be negative 31, c is 56. Most people get that. The only problem that I normally see is people add in the x there. A, b, and c are just the numbers. It's just the coefficients. If there was no number here, then that would just be a coefficient of 1, all right? Because 1 times x squared is x squared. All right, so here is the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, that's the quadratic formula. And that's what we're going to plug in. This is going to be long, but, you know, we'll deal with it. So remember, this is the negative of negative 31, right, which is positive 31, plus or minus the square root. If you don't remember why that's negative, rewind for like 10 seconds. All right. And then this is going to be b squared, so negative 31 squared, minus 4 times a times c. All right. So remember, you can always use a quadratic formula. It just takes a long time. All over 2a, 2 times 3. And then we're going to go, then we're just going to, I like to simplify the stuff inside the radical. So I'm just going to copy that down and make this a little bit smaller. Over 6. Where did I get 6? 2 times 3. 6 on the bottom. So in my calculator, I'm going to be like, okay, you got to be really careful in doing this. Let's see if we can get this all in there. So please make sure you put parentheses around that, because if you don't, you're going to get the wrong number. It's going to give you a negative instead of a positive. So squared. So remember, the square button is right there. All right. And then I'm going to put, actually, I'll just go like this. That's going to be 961. Let me just make it a little longer. And then we're going to go 4. I already dealt with the minus here, so I'm just going to go 4 times 3 times 56. And that's going to be 672. Normally I would just do it all in one go, but this is so you can check yourself to see if you did it right. All right, and then we're going to go 961 minus 672, and that's going to be 289. So this is just going to be, I'm running out of room here, so I'm just going to go equals 31 plus or minus 289 over 6, which is, again, going to equal, I'm just going to figure out what the square root of 289 is. 17. See, told you it was factorable. I know it was factorable because I have a perfect square here, so I got a 17. And now, again, it's going to be 31 plus 17, which is going to be 48 over 6, comma, 31 minus 17, which is, I'm going to mess that up, 31 minus 17 is going to be 14 over 6. And we're just going to simplify at this point. So we've got x is equal to 48 divided by 6 is going to be 8. And we're going to get a fraction here, but I can simplify, so I will just simplify. So 14 divided by 2, I think both of them go into 2, so 7 over 3. Okay, that's your answer. So again, it would have been easier to, from at this point, to factor, but if you're like, I don't want to try, then you can just use the quadratic formula, which I feel is still longer. Okay, but there are some that are going to be there that you can't factor, like factoring is not possible, and then you would have to do the quadratic formula. All right, but it wouldn't simplify to this perfect square like this one right here. It would just be like square root of 10, square root of 20, and you just have to simplify that. All right, moving on. Number 33. So I notice here that this is just x squared, but there are no other variables there. If there are no other variables there, you're just solving for x, right? So like, back in Algebra 1 where we just solve for x, this is what we're doing. So again, we're going to add 75 to both sides. And we get 5. X squared is equal to 80. And then how do we get rid of that 5? We have to divide both sides by 5. And then get x squared is equal to 5 goes into 8 one time, remainder 3, 5 goes into 36 times. Ooh, look at it. We know how to do this one. All right, and then from there, we're going to get rid of that square. The only way to do that is to square root both sides. And then we get, just put it up here, x is equal to plus or minus, the square root of 16 is going to be 4. And that's my answer. All right, don't forget the plus or minus. There are 2 different answers there. All right, getting close to being done with all the equations. All right, again, here it's a trinomial. I notice here is x to the 4th, then the next one is x squared, which means this is in quadratic form. And I would not use grouping because this is not 4 terms. So this is in quadratic form, so I'm just going to use crisscross method. So this is x squared times x squared, which is x to the 4th. 2 numbers that multiply to 8 add up to -9. I would say 8 and 1. I can't use 4 and 2 because that adds up to 6 maximum. So both of them have to be negative because negative times negative is a positive 8. So if I multiply those two, it's going to be negative 8x squared. X squared times -1 is negative x squared, which gives me negative 9x squared. So this checks out. All right, so I'm going to just x squared minus 8, x squared minus 1 equals 0. This one you can factor more, but I'm not checking for whether I could factor it completely, so I can just solve it from here. All right, I'm going to just write it over here on the right-hand side. So we're going to use the zero product property to, let me just put it down here. X squared minus 1 is equal to 0. Again, add 8 to both sides, and you're just going to get x squared is equal to 8. and then you're going to square root x squared is equal to plus or minus the square root of 8. All right. I know I can simplify this more because, okay, let me just put it up here. Let me just bring this down a bit. So the square root of 8, I'm going to simplify it more by doing the factor tree. If you remember, we're going to pull up the perfect squares. So I know that 4 times 2 is 8, and I know that 4 is 2 times 2. So I'm going to look for groups of 2. All right, so here's my group of 2. So I know, remember, this is all under the square root, so the square root of 2 times 2, which is 4. So what is the square root of 4? It's 2. And what do we have left? So this becomes this. And this right here is that 2. And some may wonder, well, what about this 4? Well, remember, we broke up the 4 by the 2 and the 2. All right, so that's why you don't use the 4, because it's already represented right here in 2 times 2. All right, so this is actually the simplified form of this square root of 8. Okay, so we're just going to go equals plus or minus 2 root. All right, we're going to do the same thing with the 1. So if we add 1 to both sides, we get x squared is equal to 1. And then if we square root both sides, we're going to get x is equal to the square root of 1. Remember, plus or minus. Well, what's the square root of 1? Plus or minus 1. So here we go. This is our answer. X is equal to, if you want to use plus or minus 1, or if you want to list them out, that's fine. So 1, negative 1, and we go 2 root 2, and negative 2 root 2. All right, so you have 4 answers. If you want to use plus or minus 1, comma, plus or minus 2 root 2, that's fine as well. All right, you just need to understand that the plus or minus 1 is actually 2 answers, okay, not 1. All right, looking at 40. Okay, 40 is going to be a little interesting. I noticed these are perfect cubes, so this is the sum of cubes, and we already talked about, well, actually, you know what, we did 125 before, so let's do 42, whereas 27, we haven't done 27 before, right? So again, I'm going to figure out what my A's and B's are. I'm going to set it up, oops, darn it, set up my perfect square, my cubes, and I know that this is going to have to equal x, because x cubed is x cubed, and what cubed will give you 27, right? 3 times 3 times 3, so that's going to be 27, so it's 3 cubed. So my A is x and my B is 3. So again, I'm going to put in x plus, it's the same, 3, and then a squared, so it's x squared, opposite, so it's going to be x times 3, which is 3x, plus, always positive, 3 squared, so which is 9. A lot of people forget to square that. All right, and then this is again still equal to 0. So again, I'm going to set both of these equal to 0. So x plus 3 equals 0. That's pretty easy. X squared minus 3x plus 9 is equal to 0. This is a quadratic. This is not factorable. I will tell you the second factor here is always not factorable. If it's a difference or sum of cubes, always not factorable. And it's going to be imaginary. So we're going to have good time fun with that. All right, so again here, this is an easy one to solve. This is just going to be negative 3. So x is equal to negative 3. However, this guy right here, it's going to be, we're going to have to use quadratic formula since it is not factorable. So again, a is equal to 1, b is equal to negative 3, c is equal to 9. All right, let's go. X equals negative b, so negative of negative 3 is positive 3, plus or minus square root, and it's going to be b squared, so negative 3 squared, minus 4a, which is 1, ooh, I'm running out of room, c, which is 9, all over 2a. All right, so let's try this out. X equals 3 plus or minus square root. Negative 3 squared is 9, minus 4 times 1 times 9 is 36, all over 2. All right, here we go. This is where our imaginary stuff comes in. So 9 minus 36 is going to be negative 27 over 2. Right, we can't have that negative 27. I am going to simplify that, so let me see how I can do that. I'll just write it underneath really small. So 3 plus or minus, remember that negative, we're going to pull on the outside as an I, right? Because remember, I is equal to, let me just write it here, I is equal to the square root of -1, okay? That's how we deal with these negatives inside the radicals, because technically it's not possible. All right, and then all over 2, and then I'm just going to simplify the square root of 27. I'm going to do that right here on the left-hand side. So the square root of 27, I know that's 9 times 3, and 9 is 3 times 3. So I know I have my doubles right here. I can use doubles here. It doesn't matter. It really doesn't matter. And so 3 times 3 is 9. So the square root of 9 is 3. So that goes on the outside. Whatever I have left, that goes on in the inside. So this is going to be 3 root 3. Ooh, the other one was 2 root 2, and now it's 3 root 3. All right, so then our answer is going to be here 3 plus or minus 3i root 3 over 2. All right, we're just going to leave it just like that. So 3 plus or minus 3i root 3 over 2. If you want to put that I at the very, very end, you can. Just make sure that it is not under the radical, because that would be radically wrong. All right. There we go. That's our answers. I know this one, whenever you get cubes, that's going to be a little bit hairy on trying to find what that 0 is going to be. Right? Imaginary roots. So it has 2 imaginary roots and 1 real root. Happy days. All right, which means that there are 3 roots, which equals up to that degree. Yeah, see, it all comes together. All right, so let's try here. So it says, write quadratic equation given the following information. You may write the equation in standard, factored, or vertex form. Just know that we're just not going to put it in standard form. It's either going to be factored or vertex form. We could always change it into the standard form, but we're not going there. All right, we'll just leave it at that. So remember, factored, we know that it gives us the roots, and the vertex form gives us the vertex. So this is how you're going to determine which one to use. So here it says write the function, blah, blah, it says roots, which means we're going to use factored form, okay? So, and it opens up and goes through the point that. So let me just write up here, factored form is going to be f of x is going to be a times x minus r1 times x minus r2. These are small subscripts just to distinguish which one is the first one, which one's the second one. That's all. It doesn't matter which order they come in. All right, so again, we're going to just do this. So I'm going to just put in what I know, because we need to know what a is. It doesn't say what a is, and just know it opens up, so which means I'm expecting a positive number. So again, this is our x, this is our y. So this is an instance that we know works. So we're going to plug these into the x and the y's to figure out what our a is. So we know that y, which is f of x, is -14. So -14, my goodness, issues. And it equals, we don't know what a is, so we're going to put in a times x, which we know for this instance is 4, minus r1, which is -3. So remember, -3, so it's minus a negative, so it makes that a +3, times x, which is 4, and then minus 5. Just like that. That's how it works. And then we're just going to simplify. So -14 times a times, this is 7, and this is 4 minus 5, which is -1. So -14 is equal to 7 times -1 is -7a. Right? We always put the number in front when they're multiplying. It's common practice. Now we're just going to solve. Divide by -7 on both sides, and we get a is equal to 2. So now we're just going to plug it in. So we got f of x is equal to, we know a is now 2, times x minus -3. So remember, minus a negative, same thing as a +3, and then x minus 5. There is my equation. Okay, that's what we got. All right, so this is what happens when you have roots. And it does open up because it is a positive 2, and it says opens up, so that matches. So happy days. All right, 49. Notice we have now a vertex, right? So if you remember vertex form, I'll just give it to you now. So f of x is equal to a times x minus h squared plus k. So h and k, it goes in that order, hk is your vertex, and then your xy is the point that goes through. Ooh, notice this does not tell us whether it goes up or down, so we won't know. And then so we can't just check on that. We're going to just plug everything that we know for this instance to figure out what a is. So we know y is 9, so we're going to go 9 is equal to a, which is the thing we're trying to find, x, which is 1. Let me see if I can make this minus h. Remember that's minus a negative 1, so that's going to be plus 1 squared plus k, so plus negative 3. I could have written minus 3, but I was already committed with the plus. So there we go. All right, so now we're just going to solve. So 9 is equal to 1 squared, oh, not 1 squared, 1 plus 1, which is 2 squared, minus, I'm just going to put minus 3. All right, and then 2 squared, we know is 4, so 4a minus 3. All right, now, oh, look, it's a two-step equation. Add 3 to both sides, and then you're going to get the answer of, that's 12 is equal to 4a, and then we got divide 4 on both sides, and then you're going to get a is equal to 3. All right, and then now we're just going to write our equation down, or our function down, I should say. So we know a is 3, parentheses x minus h, so minus a negative 1, so that's a plus 1. Don't forget the square, and that's going to be minus 3. So now that's in vertex form. Happy days, yay. Oh, and speaking of vertex form, look, it's in vertex form, and we want to graph each function. There we go. We're going to graph this guy. Okay, again, we know the vertex now. So we know the vertex is, remember, if that's a plus 2, that means it must have been a negative 2. That's a plus 1. All right, and so my vertex is there, which means, okay, so negative 2, positive 1. And if I want to find my roots, that's when y is equal to 0. So roots, 0 is equal to negative x plus 2 squared plus 1. So we're just going to solve for x. So minus 1 on both sides. Negative 1 is equal to negative x plus 2 squared. Got to get rid of that negative. So we're going to divide that by negative 1. You could also multiply by negative 1. Either way is fine because it's just negative 1. So negative 1 divided by negative 1 is positive 1 over x plus 2 squared. And then how to get rid of that square? Square root it. All right, so now we get plus or minus 1. Remember, because of what's the square root of 1? 1. X plus 2. And we're going to subtract 2 to both sides. And then we're going to get x is equal to negative 2 plus or minus 1. Now, what is that? Negative 2 plus 1 is negative 1. Actually, I should say equals. Negative 2 minus 1 is negative 3. All right, so we're at negative 1 and negative 3. That's our roots. Our y-intercept is down here. Remember, our plus 1 is not the y-intercept. How do we get the y-intercept? Remember, that's when x is equal to 0. So to find the x-intercepts, the y has to be 0. To find the y-intercepts, x has to be 0. Right? It's the opposite one. So we're just going to plug that in. So we're going to plug in f of 0. So negative 0 plus 2. Running into the graph, but that's fine. And we're just going to simplify. So this is 0 plus 2 is 2. 2 squared is 4. So remember that negative is on the outside, so it's negative 4 plus 1. So remember the parentheses, squared, that's equal to 4, but that negative comes out front because that is not part of the square. All right, and then the plus 1, so that's going to give you negative 3. So the y-intercept is 0, negative 3, which makes sense with our graph that we have. And remember, this is our axis of symmetry right here on that vertex. So our symmetrical point for the y-intercept is right over here. If it's 2 away from the AOS, it's 2 away on the other side. It's all starting to come back. All right, so let me make our parabola. Please make sure for your parabola that it's not going straight up and down, because there are some people who would do like this, and they just bring it down just like this, which is incorrect. Okay, it does not go straight, because that's not a function. You can't do that. All right, so please make sure that's slightly tilted to the left and right. All right, that's graphing vertex form. Here we have standard form. And so I'm wondering if this is factorable. This doesn't seem factorable. So we're going to have to use, you know what, the quadratic formula. We do know the AOS, right? So axis of symmetry is equal to x equals to negative b over 2a. Remember that? Remember our a is equal to negative 2, b is equal to 8, c is equal to negative 11. So it's going to be negative b, negative 8 over 2 times negative 2. So x is equal to, that's negative 4 on the bottom. So it's just going to be 2. So right here, AOS. How do I get my vertex? Vertex, remember, we're just going to plug in the x right there. X into the, so f of 2 is what we're doing. So negative 2 times 2 squared plus 8 times 2 minus 11. Running out of room. So order of operations says we do exponents first. So it's negative 2 times 4 plus, that's going to be 16 minus 11. So negative 2 times 4 is negative 8 plus 16 minus 11. Negative 8 minus 16, or negative 8 plus 16 is 8. 8 minus 11 is negative 3. Yeah, 8 minus negative 3. All right, so this is our vertex right here. When x is 2, y is 3. So on here, negative 3, just like that. And our y-intercept, remember, is when x is 0. So these become 0, and all we have left is negative 11. Only works for standard form. And then so negative 11 is our y-intercept, and our symmetrical point, if it's 2 away, it's 2 away on the other side. It's not always 2 away, it's just the way it seems to work out. All right, something like that. Notice it has no roots, so I'm not going to go and try and find the roots because I just need to try and graph it. So that's all I need to do, and I need 3 points, this many points, to be able to graph it. All right, 58. Ooh, look, it's in factored form. If it's in factored form, I know that if I want to find the roots, so 0 is equal to, this is roots, 2 times x minus 7 times x minus 4. This 2 does not have an x, so does not a root. So I'm just going to set x minus 7 equal to 0 and x minus 4 equal to 0. So my x is equal to 7 and positive 4, right? Because 7 minus 7 is 0, and 4 minus 4 is 0. So here's 7, and here's 4. Where's my AOS? Remember, it's halfway in between, so this distance is 3, so it's going to be like right here at 5.5. Okay, so I can visually just do that. So my AOS is equal to x equals to 5.5, because that's halfway in between 4 and 7, right? Remember, it was just getting the average, so 7 plus 4, divide that by 2. That would give us that too, all right? And then once I find the AOS, I'm going to just do like what we did before to find the vertex. So I'm going to just plug in the AOS. So f of 5.5, because we know that the vertex is somewhere on this line. So it's going to be 2 times 5.5 minus 7 times 5.5 minus 4. So I'm running out of room. I should have just started more left, huh? Oh well. So equals, I'll do that here, 2 times 5.5 minus 7 is going to be negative 1.5. And then 5.5 minus 4 is positive 1.5, which makes sense, right? Because if you're finding the AOS and the difference of them, it's just going to be minus 1.5 and plus 1.5, right? See how that makes sense? And then so here we go. Calculator, come help me out. I'm going to just go like this. So 2 times negative 1.5 times 1.5, which is going to be negative 4.5. All right. So my vertex is going to be 5.5, negative 4.5. There we go, my vertex, just like that. So I'm going to go down, negative 4.5. It's like that. My y-intercept, I don't think I'm going to be able to hit that, but just in case, my y-intercept is when x is equal to 0, so f of 0, remember? So we're just going to plug that in. 0 minus 7, 0 minus 4. So this is going to be 2 times negative 7 times negative 4, right? 0 minus 7. And then that's going to be 28, positive 28 times 2, 50, no, that's really big, 56, right? So it's going to be 0, 56. We're not going to even get close to that because this one only goes up to 8. So we know it's going to be like, phew. It's going to look something like that. See how it does not even get close to the y-intercept? Because we know it doesn't hit until 56. All right. That's how you graph when you have factored form. And now we have 4 terms right here. Oops, sorry. 4 terms right there. So that's going to be 4 terms. Try factoring by. I'm going to put this on the left-hand side. Normally I would write it on the right, but I don't think I'm going to have enough room there. So x cubed minus 2x squared minus 4x plus 8. I know the y-intercept right here is 8. So I know it's going to be like right there. But I don't know anything else. I know it's definitely not a parabola because x to the 3rd power. I'm going to try grouping. So x minus 2. And then these two guys right here is minus 4. I'm going to pick out a minus 4. It's going to be x minus 2 as well. All right, so negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. All right, and then I'm going to, I have these two GCF, right? So x minus 2, and this is what we have left is just the x squared minus 4. All right, and remember it's equal to 0 because we're finding the roots. All right, so I'm going to set this equal to 0. I know I can factor more, but I'm just going to solve it at this point because I'm running out of time. So again, this is going to equal x is equal to 2. Here, we know that if I add 4 on both sides, I get x squared is equal to 4. Remember how to get rid of the square? Square root both sides. So we get x is equal to the square root of 4, which is 2. So plus or minus 2. All right, I'm going to just draw that in there. So notice I have two 2's, right? So I have x is equal to 2, multiplicity of 2, because that happened 2 times, right? 2 times. And then also a negative 2. So those are my roots. So I'm going to have 1 at 2, 1 at negative 2. All right, and I know it also has to go up here, which means that, and I know at multiplicity of 2, it's going to be bouncing off here. So again, this is positive, so which means, and it's odd, so which means my arrows are going to go like this. So I'm going to start down, and then it's going to go up. So it looks like something like this. So right at this 2, I did a little bit too late, but at 2, it's going to go up just like that. All right, that's what that should look like. All right, and then 64. Let's see here. I know we have, it's a trinomial, but this one has an x back here, and this one has no coefficient. So for the roots, I know I can factor out an x, and I get x to the 4th, right? If I pull out one x, I get x to the 4th minus 13x squared. plus 36, right? Remember, this is equal to 0 because we're finding the roots. All right, and then from here, I'm going to see, well, this looks like I can factor it, like, because it's a quadratic form. Got x squared and x squared. 9 times 6, no, that would be 15. 6 times 6, that would be, oh, is it not factorable? Did I mean 12? 9 times 4. Oh, 9 times 4. Duh. You're probably sitting there like, Miss Lay, it's 9 times 4. You're right. They're both going to be negative because they multiply to be a positive and add up to be a negative. So, and I'm just going to do this in my brain right now. So x squared times 9, negative 9 is negative 9x squared. And x squared times negative 4 is negative 4x squared, which would add up to negative 13. Okay, so we're going to go straight across. So don't forget that x on the outside would be x squared minus 9. X squared minus 4 equals to 0. So we're going to set all of these equal to 0. Yes, I know I could factor more, but again, we're not checking it to see if I could factor everything. 4 equals 0. We're just trying to find the roots. So again, we get x is equal to 0. If we add 9 on both sides, we just get x squared is equal to 9. And the square root that, square root both sides, and we're going to get plus or minus 3. And here we're going to add 4 to both sides, so we get x is equal to, or x squared is equal to 4. So again, square root both sides, and what do we get? Plus or minus 2. I'm going to write the square root in there as well. All right, so I have a lot of roots here. So 0, 3, negative 3, and then 2, and negative 2. All right, that's how that's going to look. Again, this is positive. So I'm going to, and it's odd, so I know that one of the arrows, the first arrow is going to be down, the other one's going to be up. All right, and I know I'm not finding the y-intercept because I already found it. It's 0. So again, I'm going to go like this, go through, no multiplicities, and literally just weaving through. And if I do that, ooh, that was a little weird. Not this guy right here. If I do that, that's what it's going to look like. Okay, and I can check it again because I start with the arrow going down and I end up with going up. So if you do it all correctly, your arrow should come out in the right place. You should not have to force that. Okay, and that's it. So remember, the answers are all in the back, and please check your work. If I made a mistake you think, please let me know, and I will see you later. Have a good one.